Assalamualaikum warahmatullahi wabarakatuh and a very good day to all. Today, our group 4, will be presenting our Rock Dog project lab presentation. So our group consists of 4 people including me, myself, Nur Almina Jubaida bin Khalil Anwar, Nur Alia Nadirah, Nur Syafiqah Cik Yahya, and lastly Amirah Nadiah binti Anwar. So in this presentation, we will include the introduction of our lab, followed by the theory, methodology, result and discussion, and our experience from the lab, and lastly is the conclusion that we get from this lab. So for our lab presentation, there are 3 main things that we will be presenting. The first one is the synthetic gather, the second one is the anticline modeling, and lastly is the wedge modeling. So what is synthetic gather? So a synthetic seismogram or synthetic can be constructed to identify the seismic reflection, and the synthetic seismogram is also a fundamental that link between the well data to the seismic data, and it is the main tool along with the vertical seismic profile, if available, that allow geological peaks to be associated with reflection in the seismic data. And if a vertical seismic profile is available for a particular well, synthetic is not needed, and usually synthetic seismogram are created using specialized software like Rock Dog. As for the anticline modeling, so we know that an anticline is a structural trap that formed by the folding of strata into an arc-like shape. So the rock layer in an anticline trap were originally laid down horizontally, and then the earth movement caused it to fold into an arc-like shape called an anticline. So in this lab, an anticline modeling is generated, which allow us to understand the folding structure within the study area for this lab. So lastly is the wedge modeling. So we know wedge modeling is used to understand the vertical or thin bed resolution that are limited by seismic. So tuning makes 2 reflected signals appear as either one signal or even as no signal. This thickness therefore represents the minimum bed resolution that the wavelet can identify. And a wedge model allows for the analysis of seismic interference effect at an interface of increasing or decreasing thickness that are related to the elastic properties. And now I'll pass the floor to Amirah Nadiah to proceed with the methodology for synthetic gather.
Good day everyone, my name is Amirah Nadiah binti Anwar, and for my part I will be explaining on the workflow incorporated for the synthetic gather. So this project workflow will cover from the first step up until the last step, which is the final view of the well viewer for all the gathers. So first, from the well viewer window, we go to the Z stick and take the MD, and we ensure that all the tabs at the right sidebar of the well viewer have turned off, and if not, the tick option will be grayed out. And then we go to the well ops, we go to the synthetics and filter and synthetic generation AVO. And then the synthetic generation AVO tab will appear on the right sidebar of the well viewer. And then we ensure that the VPVS row sets is in use is in WTR, and then we click on the wavelet. In select wavelet window, we click on the create recur, and then from the pop-up input dialog, specify the sample interval as 2.0 ms, frequency as 25 Hz, and name as R25, and then we click OK. The select wavelet window will show the wavelet created, and then we click OK to proceed. And then ensure that the reflectivity parameters and angle parameters are correct. We click calculate. Click on the calculate. The calculated synthetic gathers will appear in temp log tracks together with AVO cross plot of reflectivity versus angle. And then name the calculated gather as gather WTR in outputs column, and then we click save. And then the scale of AVO cross plot can be changed by right click the cross plot, then go to the left axis, and then we tick on the set scale. So repeat the same process for the right axis. And then in the synthetic generation AVO tab, we click on the VP-VS row. And then following from that, in the select VP-VS row set, select or highlight the gas set and click OK. And then click calculate, and we name the gather as gather_GAS, and then we click save gather. So we repeat the steps 12 until 14 for VP-VS row set for oil and save as gather_OIL. And then right click on the rightmost side of the log track. So we go to the new track and we add gather track. So in gather track, right click and then go to the select gather 1. And in select gather window, select the gather WTR and then we click OK. So we set the scale of AVO cross plot at bottom of the track by right click on the cross plot and go to the left axis, and then we set the scale. So repeat the same procedure for the right axis. To make the gather neater, right click on the gather tracks and go to the display option. So in the gather display option window, we tick on the user defined data in angle offset column. So we set the plot angle as near as 0, far as 45, and with increment of 3, and then we click OK. So resulting gather_WTR tracks, and then we have to repeat the step 16 to 22 gather oil and gather gas. Now the blue line and red line on the gather track indicate the measurement of gather to be analyzed in the cross plot below. So play by dragging the line along the log interval and see the resulting AVO cross plot. And then lastly, final view of the well viewer with gather WTR, gather oil and gather gas will be appear. So from the steps that we have incorporated within the synthetic gather workflow, this would be the final outcome for the synthetic gather. And then this would be the synthetic gather results, which is focusing on the Jubilee Formation. And now I will pass to Nur Shafiqah to explain more on the anticline modeling.
So now I will proceed with anticline modeling workflow. From the project viewer, select rod.2d, select new session, then rename the session to the anticline. Then select OK on the log and mineral start. After that, to create an event, right-click the model view and select Add Event. Name the event as Reservoir and then click OK. And then left-click the model on the trace 0 at around 2100 meter to digitize the first point. Create another on trace 50 at around 1870 meter and the trace at 99 at 2100 meter. Then double-click to finish digitizing. After that, create another event by right-click on the event folder at the left side. Right-click it and select Add From Event and name the event as Under Burden. Then set the reservoir as the original event and the vertical offset of 50 meter, then click OK. The base reservoir is added to the reservoir. To create zone, select the Geological Modeling tab and select Make Zone. Then the Edit Zone fields is open. Select the Model Top tab and rename the zone as Overburden. And set the zone to average set. Next, for reservoir, select the VP table, then from the copy from the average set button, select lower man X water, then click OK. Repeat the process for the reservoir zone, but select the Jubilee water and the other underburden as Upper Atlas water, then click OK to dismiss the dialog. Rod.dot create the base scenario model, so open the model and all the subfolder. In the reflectivity folder, a 0 degree zeoprit synthetic being created. Activate the checkbox to display the synthetic. By default, Rod.dot crops the synthetic half away from the edge of the model. To override this, right-click on the zero equals to 0 attributes and select calculation range and select entire model. Then to model a full start response, right-click on the attribute again and select change angle. Then select multi and set the range from 8 to 40 with increment on 8. After that, to create fluid context, open the zone folder, right-click on the reservoir and select the set fluid context. And then activate the GOC and OWC checkbox. GOC equals to red shade and OWC equals to green shade, and then click OK. After that, to handle appear in the trace 0, drag it to our desired location, then right click on the base scenario model. Select Gasman Dry Rock Modeling Fit sub, and then click on the select zone and select the reservoir by double clicking the left hand column. Then for mineral set, select Hanshin treatment weighting, then click on Dry Rock Modeling tab. After that, on the Dry to Final tab, set the gas slide saturation to gas equals to 0.9, water equals to 0.1, and click Calculate. Click Save and close the dialog. A new model named Dynamic Scenario Model appear, and open the folder, the DRM model and the reflectivities folder. And lastly, activate the Zeoprit full stack synthetic and observe the properties by activating the checkbox. So this is the anticline modeling result that we get. So the outcome result is the left side. The expected result is a bit different with the outcome result because of there is a problem with our data.
Next, moving on to the wedge modeling. So firstly, for the methodology, we open the rock.2D and then select new tuning wedge and select well, and then select and choose Norton 2, and then we press OK. And then after that, select the upper marker. We select Jubilee and then OK. And then for lower marker, select upper atlas and press OK. And then select markers, lots and minerals and saturation, and select OK as well. And then after that, go to edit zone lots and then select the model top tab and rename the zone to lower mass, and then press OK. And then the model viewing window will show the tuning wedge. Then after that, we open the base scenario model and open reflectiveness and click ZOE_0 synthetic. And then after that, right click at the ZOE_0, then go to calculation range, then choose entire model. And then after that, we change the angle by choosing ZOE_0. Then after that, change from single to multi, which set the minimum 8 and maximum 40 with the increment 8. And after that, we right click and choose measure attributes. And after that, we choose the measurement category, thickness, measuring type, which is TVDSS. Okay, continue with the methodology. Then the upper event we set to Jubilee, and then the lower event we set to the upper atlas, and set the new color as per preference and rename to the true thickness and click OK. Then for the apparent thickness, right click again and choose measurement attribute. Then after that, for category, choose thickness and create new measurement. For a measurement event, select Jubilee, and then snap event, choose nearest mean and choose ZOE_8_40. And then after that, we display event, which change the name to apparent top and click apply, and then click OK and new. And we repeat the same step for measurement event and choose upper atlas and snap to the nearest max and choose ZOE_8_40. And then after that, we display option, which change the name to apparent base, and we apply and then click OK. After that, we repeat the step for measurement attribute and choose the upper event, the apparent top and lower event as apparent base. And then after that, we choose color and set the name to apparent thickness, and then we click OK. And lastly, we choose color and set the name to apparent thickness and click OK. And then we we set the range for the measurement by right click, which is the minimum 0 and the maximum is 80. So this is the result that we get for the wedge modeling. So the upper one shows the outcome result that we get from the lab, and the the below one is the expected outcome. As you can see there, the graph is quite different, and also maybe the color also different. Maybe it might be due to the error in data, or there's something wrong with the software.
So now is our experience from this lab. So I am so happy to be in this lab actually, because I am able to familiar with the geological modeling software that is relevant to the industry, and the software that can be used to understand the rock physics even further. Moreover, I get to learn the theory in class and to practice them in the lab. And from what I get is this lab also give us some exposure to a well-logged example data from the offshore, even though it was a bit difficult at first to understand, but then as we are progressing further, I can grasp the concept from this lab. Overall, I think this lab, it was a fascinating lab session, and I am so grateful to learn with our lecturers as well as our helpful GA, Mr. Rafael, Mr. Faris, and Mr. Basil, that help us and lessen the tension during the lab session.
The experience that I get from the lab session, first, I get to new knowledge about the software that is related to the industry, and I can apply the knowledge learned in the class into the lab session. While using the software, I have a bit challenging as need to start from zero knowledge and many steps involved, and then lastly, the software skill can be learned, can be applied while working in the same field, which is rock physics.
Along the learning of these 12 weeks for the subject, I was able to understand the science behind the rock physics concept, which its main objective is to address the relationship between the geophysical observation and the underlying physical properties of rocks, such as the composition, the porosity, and the pore fluid content. Now, the aim towards this was able to be achieved through my lab session learning, which incorporated the use of RockDoc software. I would like to thank my lecturer as well as to my GAs, who have been a very big help in assisting the students to be familiar with the software.
First of all, I would like to thank to our lecturer, Dr. Maman, and also our GAs for helping us throughout this lab. So from my experience during this lab, it was really fun actually. And the GAs are supporting and also really helpful, especially when we don't get how to do that, and they really help us. But there's a problem with the software, I think, because sometimes we cannot get the result that actually what we get the result, we don't get the result that is desired to get that. And then also, okay, once again, thank you very much for guiding us throughout this lab. And also, that's our first time to hear about RockDoc, but we managed to get the idea and the knowledge about the software, and we can apply it in the future, especially maybe in the rock physics field. Thank you so much.